Hello, my name is Bishar Musipal and today I am going to represent what is superparamagnetism and magnetic nanoparticles and magnetic hyperthermia. Superparamagnetism is the property occurring principally in small single domain magnetic particle without magnetic memory. It is more closely related to the ferromagnetism than to the paramagnetism, as we can see here in the below diagram. Property of superparamagnetism: near relaxation time. Near relaxation time, the attempted time uh, or the period. It is usually range from 10 raised per 9 to 10 raised per minus 12 second. Blocking temperature. An other factor in superparamagnetism is the measurement time. When the measurement time is much less than the relaxation time, a block state occurs in which the measured magnetization is just instantaneous magnetization at the beginning of the measurement because there was no direction flip. When the measurement time is much greater than the relaxation time, the result in the superparamagnetic state. Magnetization curve. When an external magnetic field is applied to the superparamagnetic particle, the particle have a net magnetization because the magnetic moment of the particle will begin to align with the applied field. Size dependence. The ferromagnetic response has a hysteresis loop. When the ferromagnetic particle increase in size, the magnetic moment increase, which in turn increase the magnetization and allow the magnetization to reach its saturation. This translates to a thinner hysteresis loop. Magnetic nanoparticle. Magnetic nanoparticle are a class of nanoparticle that can be manipulated because using magnetic field. Such particle commonly consist of two components: magnetic material, often iron, nickel and cobalt, and the chemical component. There are functionality. Application of nanomagnetic particle. Fluorescent biological labels, drug gene delivery, biodetection of pathogen, detection of protein, probing of DNA structure, tissue engineering, tumor destruction via heating, hyperthermia, separation and purification of biological molecules and cells, MRI, contrast enhancement, phagokinetic studies. A recent development in magnetic nanoparticle is tissue engineering, cancer therapy, multicolor optical coding for the biological assays, manipulation of cells and biomolecules, protein detection. Hyperthermia. Hyperthermia system that is able to heat tumor cell above 43 Celsius without damaging normal tissue is required. Hyperthermia can be created artificially by drugs or medical devices. Hyperthermia therapy may be used to treat some kind of cancer and other condition, most commonly in conjunction with radiotherapy. It is known that cancer cells show more weakness to high temperature compared with ordinary cell. Hyperthermia is an elevated body temperature due to failed thermoregulation. Hyperthermia occurs when the body produces or absorbs more heat than it can dissipate. Magnetic hyperthermia. Magnetic hyperthermia is another experimental technique for cancer based on the fact that magnetic nanoparticle can transform electromagnetic energy from external high frequency field heat The advantage of magnetic hyperthermia. Magnetic movement on the nanoparticle will align with an external magnetic field. As the external field changes direction, magnetic movement will also change the direction. It produces dissipation leading to the heat. One of the major advantages of using the magnetic field to produce heating is that they readily penetrate tissue. However, heating the surrounding tissue can also produce unwelcome side effects, so there are advantages strictly control the region under treatment by using magnetic nanoparticle as the heating element. Superparamagnetic nanoparticle absorb power from AC magnetic field and heat surrounding tissue while Neil or Brownian relaxation and hysteresis loop. Thank you.